Anyways, today let's talk about Python modules that you can import. Well, so basically there are certain Python modules that people use all the time, but you have to import it first. For example, one of the more useful one, well, it's called the random module, and it does what you think it does. It's basically anything to do with random. So I could import random, and that imports the random module. Now, it's random is very useful, but to use it, you have to do like random dot anything for the function. So I could say random dot random, just random, picks a random number, and if I print the value of random dot random, well, it's always a number between 0 and 1. That's random dot random. Now say you want like a random integer instead of just any decimal between 0 and 1, right? Well, there is a function called random.randint. And what this does is that it will choose a random number between the two numbers you typed in. For example, if I do 0 through 5, this is a bit different from the other functions. The 5 is also included. The upper bound and the lower bound are both included. See, it gives me 4 right now. See, 5. So 5 does pop up, unlike some other functions. But for the most part, it just picks a random integer between the two values you typed in. That's what it does. Now, those are the two most used functions, I think. Those are actually, I think, about like the two only ways you would use random. It's either to pick a random number between 0 and 1, and to choose a random integer between two values. And with random, well, we can do a lot of interesting things. So like we could even make a number guessing game. We could say number equals, well, I guess I have to import random first. This is very important. If you do not import random, you cannot use anything random related. So I could say number equals random dot random between 0 and 100, right? So I could say your guess equals guess my number between 0 and 100, right? And well, I could convert it to an integer. First, I can set guess to like -1 so that it's guaranteed not there and not inside the range, so it's wrong, right? So I could say while guess is not equal to, well, guess is not equal to number, right? Get the new guess. I can say try, right? Try to convert it into an integer number and accept value error. Well, prints invalid input. Well, I guess I will also add the \n. \n stands for a new line. This will make make it such that whatever after it goes on a new line. And then now it just plays, but it doesn't give any feedback, right? So I could say give so I could say if it's too big or too small. And I could even yeah, so we can say if guess is greater than number, friends, too big. Try again. And then elif, right? Remember else if? I could say if guess is smaller than the number, then say too small. Try again. And then else if they're, which basically can only be if they're equal. Print. You got the number. And then now we can, this is now a working game. Guess a number between 0 and 100. Like 50. Too small. Guess again. See, now we have a working game, right? And then, yay, the number is 82. But we could also keep track of how many tries we took. And then we could add tries by one after the guess, after you input the guess. So that if you throw in an invalid guess, it's not a number, it doesn't count towards the tries. Like I say, you got a number and well plus convert tries to string and well, tries. Now I could say guess 50 too small. I guess 75, well too big. I guess 62 too small. And if I just type empty, it's invalid input. If I type like random, it's also not a number, so invalid input. Yes, 70, oh, it's too small. 73, too big. Is it 72? Nope, is it 71? Yeah, I got it in 7 tries, right? So if we count up the tries I took, guess 50, 75, 62, 70, and 73, 72, and 71. That's 7 tries without counting the invalid inputs. Yay. But it's, this part can actually be written in another way that is a little bit better. So in Python, there's a thing called f strings. And what you do, well, we want to have this tries variable in here, right? In some, so that we can say you got a number in something tries. Well, what you can do in Python is that if you put an f before the string, hence the name f string, and then you type curly brackets inside, then you can say tries with curly bracket around it. And what this will do is that it will plug in the value of tries. So if we give it a test, I got the number in 7 tries, just like before, but none of the adding strings together. Yep. Are we following up so far? Am I moving too fast or are we all good? No response. I guess we're all good then. Well, that's the random module for you. So with the random module, you can make lots of interesting things. This is just one example of using random. So well, there are more modules than just random, right? For example, there's a thing called time, and time module is everything time related. For example, you could say print first print, and then there's a thing called time.sleep. What this does is that it basically pauses the program for however seconds. So if I say time.sleep parentheses 5, it will stop the program for 5 seconds basically. So print second print, right? Oh, first print, and 5 seconds later, second print, right? So that's time.sleep. So that's one use case of time.sleep, right? But well, there's a lot of things that you can do with time, right? So there's get clock info, see time, everything, local time. Right? There's a lot of things in time. For example, I could even do this, right? And this gives me my local time. It says it's 2022, June 29th at, well, what is this? But yeah, see, you have a lot of information. So there's a lot of functions, and I do not remember what every single one of them does because I don't use this quite often, but it is useful in some cases. Mainly just to get the time or time.sleep. Or well, there's a thing called time.time. And it gives you the current time in seconds. But how can you tell time with only seconds, right? Well, time.time gives you, I think the time, like the seconds after 1970 of January 1st at 12. It's every second after that time is counting. See, if we read the description of time, it is generally from from January 1st, 1970, right? So that's the time module. So the time module, well, you can use it to time programs, right? For example, I could say starting time, right? I could even time our game. could say starting time equals this. And then if you got it, we have a ending time, right? And then I guess we should put this in front of the print so that we're timing before you get the result. And then we can say you got the number. Well, this is a bit wrong, but you got the number in, well, tries within how many seconds, right? I can say ending time subtract starting time. And now our game is timed. And then now it's timing my game. Got the number in 7 tries within, well, 14 point something something seconds. Now that is kind of annoying, so let's convert that to an integer. Which, if you convert a decimal to an integer, it doesn't round it to the nearest integer, it rounds it down. So if you have 14.9 and you try to convert it to an integer, well, it's going to give you 14. You may think it's closer to 15, but the computer says, nope, chop off everything after the decimal point. So this is how you can use a time module. See, it gives you the tries and the time I took. Okay. Do we have any questions so far? Because after this, I'm going to start talking about some more advanced, complicated Python things. I just want to make sure that everyone sort of understands what's happening. Yeah. If you know, understand everything, then well, type something in chat to show me that to tell me that you understand this now. Or not, then I will explain. All right. Good, good. All right. Great. Well, let's move on to another very important Python topic. Let's cast all this aside for now. And have you guys ever heard of the thing called a class before in Python? Class. So before this, we have, well, we have numbers, right? Numbers, we call them integers, and then we have decimal numbers and we call them floats. And we have, well, words, and those are called strings, right? And we have, well, true and false. Those are all objects. Object as in they're things with attributes. For example, a number has a value, right? A word, well, it has a length. Well, I guess not in Python maybe, but most basically it's you can call many things on them, right? They'll have their own attributes. Well, class, what it does is that you're basically making your own object thing, right? like a class. So yeah, class. Well, does anyone have any interesting ideas that I could steal, or I'll have to come up with one on the spot? Anyone have a fun name that I could maybe use? Oh, anyways, yes, class. We can. Let me think. We could like class number. Suppose we're class butterfly. Sure, actually. And for class, it's a common practice to make the name capitalized. All right, so now we have butterfly, but it's empty, right? There's nothing in it. So let's give it some properties, shall we? So this is how you give butterfly properties. So just like how you define a function, right? You would define and, well, two underscores init, two underscores, parentheses, self. Why is it like this? I do not know. But init is what it does when you make a butterfly. So this is what initializes the object we're saying. So well, our butterfly can have a color, right? We can say color equals purple, right? But then you can only use this color within the butterfly, and no one else can ever know what the butterfly is. So what we actually want to do is we can type self.color. So now, if we make a butterfly, right? If we do equals butterfly, and this is how you make an object. Instead of saying butterfly, say butterfly in parentheses to show that you're making a new object. So now we have a butterfly, right? And we can print, well, guess we can print b butterfly dot color. It has a color. It's purple. But well, not all butterflies are purple. I'm sure basically no butterflies are purple. I don't even know, right? And I'm sure they're not all the same color. So we can, well, just add color, add a color parameter. So now when we make a butterfly, we have to say its color. So suppose we want a green butterfly somehow. Well, we have a green butterfly and we can change the color now with this color, right? So, well, how will we add more attributes or things about the butterfly? Maybe we want like a size, right? Like how big is it? Delta size equals, let's say equals size. We could say it's a green and small butterfly. And when we type b.color, well, the butterfly is green for this butterfly, right? So the size is small. And we can even make another butterfly with different attributes. It's like how we can make different words, different numbers. We could say it's a white and big butterfly. So now b.color, it's still this butterfly's color, which is green. Well, b2 is white, right? So if we do b2.color, It's white. Give me 30 seconds, I'll be back in a bit. Okay, well, I am back. So we have butterfly color, right? But similarly, we can also say, well, butterfly size. Well, the first butterfly, B, is small because we set size to small, and then now it has a small, right? But, well, what happens if we do butterfly the size? Well, it doesn't really exist, right? Butterfly does have a size if you make a butterfly, but this is not a butterfly object. This is the like how you define a butterfly, and it is different. It's kind of like the difference between, say, a number like 1, 2, 3, 4, 5, right? And the definition of a number. They're kind of different. Well, what can we do with classes, right? Well, we can define their own functions. Yeah, so anyone wanna tell me like what a butterfly can do, like except fly? I don't know, define fly maybe. And then maybe say like the butterfly is flying, right? So if I do, so what we can actually do is, well, we can call the function now, right? We can say this butterfly and make it fly. And this is the important part I forgot. Every function within this class, you have to add a self as a parameter. It has to run with itself, right? You have to run this function through itself. So when we do b dot fly, we're making the butterfly b do this fly function. So I could say the self color and self dot size, butterfly is flying. So now when we do b dot fly, it says the green and small butterfly is flying. And now if we call b2 dot fly, it's going to say the white and big butterfly is flying. And well, nothing is stopping us from making more functions, right? So we could even define, well, functions that changes its color. So we can say define change color. Then we can give a new color. No? Well, what we can do is that we can set self.color to new color. This can be, well, I just forgot it again, but you have to add self for every single function's parameter. So if we do self.color equals new color, right? And then if we say b2.change color, somehow a white butterfly just became a red butterfly. Then we copy b2.fly again. Well, it just changed to red and the fly again, right? So now, see, we can have functions that somehow changes your initial numbers and values. Yep. This part is a bit complicated, I know. So if you don't understand or have any questions, please just ask. Yep, so are we all good with these basic class functions so far? Are we good with these? So we have butterfly right now, right? But here's this, here's something that doesn't quite work. When you try to print a butterfly, it says a butterfly object at this location, right? Well, there's actually several ways we could change that, right? But this is how you change it, change how the print function interacts with your class. So once again, define and double underscore, but you will do REPR. This stands for representation. So how it's represented, right? So we could say, no, have to return a value, right? How it's represented. So I would say self.color, self.size, butterfly. So now when we print B, well, it's a green and small butterfly. This is how you can change it, how the print function interacts with the class. Now, well, what if we want to print, well, what if we want to convert this to a string? It still says green and small butterfly, right? But there's actually a function for this as well. So to change how it interacts with the string function, there's a function called, well, double underscore str double underscore. Well, it stands for string. This deals with how you want to represent this thing when you try to make it a string. So I could do the same thing, except maybe I will swap the order this time, so we can see it working. Well, if I try to print after converting B to a string using this function that we just made, small and green butterfly, because when you try to convert to a string, it runs this one. And when you try to print it, it runs this one, this represent function. And if this doesn't exist, it tries to convert it to a string. So if it is print B, well, I guess it's still small and green butterfly. It tries to check if it can convert to a string first. So now I said it's green and small. So yep, priorities. So yeah, do we understand everything so far? Or do we have any questions? No. If you're all good and don't have any questions, please type something in chat so that I know, because we're going to get started on the first somewhat big project. So if you're good with everything so far, can you let me know in chat so I can continue? Do we have any questions? Anything? No? All right. Have any of you guys heard of this game called Minesweeper? Oh, does typing print REPR of P work? Let's see. First of all, REPR, well, I guess it does. REPR gets the representation. Technically, it should work. And it does work, yes. It's kind of like string, but then they're kind of the same thing, honestly. But this is this only works with print, right? But str instead, well, yeah, it works with converting it to a string, which the represent REPR function only tries to call the double underscore REPR, and print actually tries to convert it to a string first. So yeah. However, REPR is it's not really used very much, and most of the time you would just do this instead of well typing REPR of B, right? Oh, yeah. And it has to return, well, a string. So well, I could make it return nothing. So this is how you can change your representation. Yep. Anyone else have any questions, or are we all good? Yeah. All right, tell me, who has played or seen Minesweeper before? If no, it's fine. Just let me know. Because if you don't know what Minesweeper is, I might have to do some introduction for that first. All right, type yes if you know and type no if you don't. Minesweeper. All right. Minesweeper, no. All right. So here's Minesweeper, right? Okay, here's a simple Google version, but anyways. So it's a game where you have a bunch of squares that are not revealed, and whenever you click, well, every single square for those that have a number, it says how many mines are around. And your goal is to put a flag on all the mines while not clicking on the mine. So if you click on mine, you lose. That's it. That's basically it. Have we ever seen it before? No? This is Minesweeper. It's a really old game. So yeah, we will be making this in Python, but well, not with this fancy graphics. So how it works is that, yeah, all these numbers just represent how many, well, mines or bombs are immediately around it. So for example, this one here, well, yeah, 1989 initial release date, very old, yeah. It's a very interesting game, right? It gives you a lot to think, and it's definitely skill required, and it's a lot of thinking. But let me tell you, it is really fun, right? So if you click on a mine, well, obviously you lose, but yeah. So we're going to make that in Python. So for the first time, let's make a new project. So let's go back to our main Replit page. And well, let's create a new project. What? We can call it. We're also going to use Python again. And the title will be Minesweeper. And create Replit. New REPL. And yeah. So let's begin thinking about, well, what does a Minesweeper game have? Let's look at what they have. Well, they do have a timer after you click for the first time. That is, I guess we can import time first. And well, I guess we have to import random too, because we want the mines to be in random locations, right? But before all of this, well, remember what I said about making our own objects with class? Well, we could make class square for every single square on the screen, right? Well, what does every single square have? It has a number, and it may or may not have a mine. So here's what we are gonna do. Once again, define and initialize, right? And well, first of all, self. And what goes into a square? Well, how many mines are around it? But we don't quite know how many mines are around it. And we can't just say, well, set it to some number without knowing it, right? So what we are going to do is that, well, initialize with just self. And we can set like self the number. Well, set it to 0 initially. And we can have self dot is a mine and have it equals false initially. And well, remember when we click on a square, it reveals it. And when we don't click on it, it's not revealed, right? See, the squares are covered until we click on it, right? So, well, we could have a self dot revealed and it equals false, right? So now we can, well, test it out. Make a square. Make a square object. Well, let's define how we are going to represent it. Right? So if you do define REPR self, well, it's just a number, right? So basically not print, but return self.number. That's how you would represent it. And well, I guess I have to do str and self wait. What? That's odd. Oh, I am dumb. It says return the non-string. It has to return a string instead of a number. So what we do is just convert it to a string. And it says 0, right? But well, if it's 0, then it's blank. And if it's numbers, then it's not blank. So what we want to do is that well, we will only want to give the number if it's revealed, right? It's like we could say if self.revealed, then return convert to string of your own number. And if it's not revealed, return us just empty space. So now when we print s, well, we get an empty space, right? So that's how we have, well, a square. So well, after the square, we have a board, right? Well, remember when I said list in lists, this is where it comes in very handy, especially with for loops. So here's what we can do. For, right? So first of all, we can have board equals an empty list. For I in well range, let's make a 10 by 10 board. And we can just type 10 if we want 0 through 9. We can say board.append. Remember, append adds a new thing at the end of the list. And we can add an empty list at the end. Well, for J range, also 10, we want a 10 by 10 board. And remember what I said about indexes? And what do we do if we want to read the last one? Last element of a list, we can do -1. Well, since it's also an empty list, we can append, well, a new square, right? Well, we can just use this list of lists as a board. Why not make a class for it as well? Class board, right? Define init of self. And we can put all this in here and call it self.board, right? So now it is a board object with a self.board. So now it has a list of lists, but it's a board object. Now you may ask, how is this useful, right? well, we can actually, well, define how it's represented, right? Define how it is represented. So what we can do is that we can just make outlines of squares with the squares in the middle, right? So what I could say is, first of all, I can say output equals empty string, right? And then return output at the end. Now it's what we do in between. Output plus equals, well, the top line, right? So what we want to do is that we want to multiply it by, well, if it's a 10 by 10, but we have to have vertical lines too. So what we can actually do is ignore the top lines. And we can do 4, right? For every single line, for, well, instead of, I guess we could say for line inside of the board, and for square in line, right? Now this will go through every square. And instead of REPR, we could type STR instead, right? And well, what we want to do is output, add add the number that represents the square, right? And then also add something that separates them. And at the end of every line, output plus equals, well, make a new line and also a lot of some separators, right? So here we can just say, well, times, since it's a 10 by 10 board, just want 20 basically. And then also make a new line after. So if I say, well, if B is equal to board, that was bad practice by me, should make the B capitalized. But if I make a board, well, now, well, it makes a board now, except all the squares are empty. Now, if you don't want the outside lines, or if you want more lines on the left and top side as well, it's pretty easy to fix it. So I could just steal this and set it to the output initially, and this will settle the top of, this will settle the top line. And now what about the left side line? To add a line on the left as well. Before we add off this, we can say add a line, vertical line first. And now boom, we have a board. Yay, isn't that great? Now this is a bit squished, right? But there's no easy way of fixing it, so we will stick with this for now. All right, does anyone have any questions? If not, we will call it a day, and I will see you guys next week.